Hey, ladies and gentlemen, 9.2 is entitled Angular Momentum. And just like we have linear momentum, how fast something is going multiplied by its mass, we also have angular momentum. So, angular momentum, regular momentum, linear momentum is mass times your velocity. Angular momentum is equal to its mass, but remember, it's not only where its mass, how much its mass is, but it's also where it's located. So we use the moment of inertia. And its velocity is angular velocity. So just like we've got mass times velocity, we've got its mass, but it depends on how much it is and where it is. Is it a hoop? Is it a solid? Is it a sphere? And how fast it's spinning. And just like we had before, we had that impulse momentum theorem, that F delta T equals m delta v. There's also an impulse momentum theorem for angular momentum. So instead of force, we're going to use torque times your change in time. So if you exert a torque on something for a certain amount of time, then that equals its mass, moments of inertia, times its change in angular velocity. So this is the impulse momentum theorem for impulse angular momentum theorem. So I've got a couple of videos that kind of just show you some really cool examples of this guy right here. It's really neat how this thing works. And the first one I want to show you is a guy doing a high dive. Now, if your angular momentum stays constant, and if you start changing your shape, which means that you're altering your moment of inertia, so you make that radius smaller, well, if this moment of inertia goes down, then your angular velocity is going to go up. Let me show you. So this guy, he sets the world record for high dive. It's 172 feet. It's really crazy high up there. Let's see where we want to start it.
Dana, that's all I was going to ask you. You've seen the other.
So they're
guys,
interviewing him at the
everybody
top
was
of this thing,
fairly
which is
safe,
just
but,
absolutely crazy.
Nobody really put one in there.
Yeah, that's true. Golly, I'd like to put one in there.
All right, we'll wish you good luck.
And if you
and
watch
go
him,
for it, buddy.
when he jumps, he's actually going to control his rate of spin by altering his physical shape. He's going to get larger. He's got a bigger moment of inertia, so he has a smaller angular velocity, so he'll spin slower when he gets higher, taller versus more compact. He's got these, he tapes up his knees because he hits feet first, and it literally like blow his skin apart if he didn't like tape up his knees. It's just absolutely nuts. 172 feet, I can't imagine that.
Oktoberfest in Germany, etc., performing for the crowds, and they know how to salute, and they know how to give a smile even when they're hurting, when they hit bottom.
I'm making a video.
His dive is far more difficult than any dive that the other competitors have used. It's a reverse triple somersault. Boccia did a single somersault, and most of the other competitors did double somersaults. He's doing a reverse triple somersault back towards the platform.
Here he goes.
You can see him going through some of his arm movements. There he goes.
Good jump. He's in good shape. He knows where it is.
Unbelievable. Let's watch that again. Watch how when he gets larger, he spins slower. So here he goes.
Single somersault. Most of the other
He
competitors
tucks,
do double somersaults.
and he
He's
makes
doing the
himself
reverse triple
spin really
somersault back
fast.
towards the platform.
You can see him going through some of his arm
Tuck,
movements. There
spin
he goes.
fast. He opens up,
He's
slow,
in good
fast,
shape. He
slow.
knows where it is.
Boom.
He drilled it. Won't wave it. They're gonna take.
Love it. Another prime example of conservation of angular momentum is ice skaters. What they do, they start out and then they bring themselves in, which lowers their moment of inertia, which increases their angular velocity. 308 RPM. Woo! That's quite fast. So this is the second part of 9.1, angular momentum, meaning that just like we've got linear momentum, how it's your mass times your velocity, angular momentum is your moment of inertia times your angular velocity. And if you exert a force on someone for a certain amount of time, you'll change their momentum. If you exert a torque on someone for a certain amount of time, you'll change their angular momentum.